Okay, let's go through the answers to these questions. So, first one, there's a little bit of a typo. That should say proton. Okay, so you want to find the de Broglie wavelength for a proton moving at 3 by 10 to the 7 meters per second. It could be a photon because they'll move at the speed of light 3 by 10 to the 8 meters per second. So we just use de Broglie's equation. Put in our values. Planck's constant is just from your data sheet. Divided by mass of proton, which is on your data sheet and given at the bottom of the page, times its velocity. Okay, so remember, when we're dealing with particles, we can use momentum, letter P, is equal to mass times velocity. Type all that into your calculator and you should get that as 3.97 by 10 to the minus 7. And it's a wavelength, so even though it's a de Broglie wavelength, there's an associated wavelength, it's still meters that we measured it. B, a little bit trickier. We are told an electron has a kinetic energy of 1.6 by 10 to the minus 17. So we need to start off with our kinetic energy equation, equals a half mv squared. Putting in our values. Mass of an electron is 9.11 by 10 to the minus 31 times v squared. Rearranging that gives you the v is 5.927 by 10 to the 6 meters per second. Then we can use that in our de Broglie equation to find the de Broglie wavelength. So that'll be h over mv, which is just equal to 6.63 by 10 to the minus 34 divided by mass of an electron, 9.11 by 10 to the minus 31, multiplied by the velocity that we worked out before, 5.927 by 10 to the 6. Type that into your calculator and it gives you 1.23 by 10 to the minus 10 meters. Next question is working the other way around. So we're given the de Broglie wavelength and we have to work out the velocity. So our equation is that, but we can just put in that that's equal to, the momentum is just m times v. So putting in our values then, we're told that the wavelength is 5 by 10 to the minus 11 equals 6.63 by 10 to the minus 34 divided by mass of electron multiplied by v. Rearranging that gives you v is 1.46 by 10 to the 6. That's the velocity, so it's meters per second. Last one, calculate the momentum of a photon. That is the correct spelling there. So we're looking at a photon of light if it has a wavelength of 700 nanometers. So we're looking at the momentum carried really in a red photon because that's what this relates to. So our momentum of our photon is just Planck's constant divided by the wavelength. Remember to convert from your nanometers into meters, and that gives you that it's 9.47 by 10 to the minus 28. It's a momentum, which usually would be kilograms, mass multiplied with velocity, so kilograms meters per second.